Good afternoon, ladies and gentlemen. I'm Russell Hines, Principal BIM Consultant at Rapid 5D, and I'll be chairing today's webinar. It's my pleasure to welcome to you and to this online presentation by myself and John Boothman, the Engineering Manager at Morgan Sindall. This afternoon's presentation will focus on implementing BIM at Manchester Victoria Station redevelopment, and John will provide an overview which will cover the BIM process, infrastructure specialities, BIM to field and back, and virtual design to construction. Following the presentation, we'll be able to answer some of your questions, which you can submit using the Q&A box on the right-hand side of your screen. Please ensure the Q&A window is expanded, and to pose a question, simply type your query in the small window at the bottom of the screen, click Ask, and choose All Panelists, and then press Send. Although we'll not be answering any of the questions until after the presentation, we can encourage you to submit them throughout, and we'll pick those up at the end. I'm now delighted to introduce our speaker, John Boothman. John is a civil engineer with over 40 years' experience of delivering complex, multidiscipline infrastructure projects in both rail and highways. He is the engineering manager for the contractor at Victoria Station, and as such is overseeing both the Network Rail station works and the Metrolink Transstop works. I'll now hand you over to John, who's going to start the presentation for you.
Good afternoon. Right, Victoria Station, located in the centre of Manchester, until recently has had the very unwelcome accolade of being titled the worst station in the UK. However, as part of Network Rail's major infrastructure and rail expansion and electrification expansion, that's due, known as the Northern Hub, Network Rail identified that Victoria would play an elemental part of their expansion, and so they appointed Morgan Sindall to design a contemporary roof structure which would provide a bright, efficient, spacious, and above all, a safe environment, and act as a genuine focus for the new high-capacity train and tram services. And note the blue sky, it does actually happen in Manchester, but perhaps not quite as often as we would like. So there are a number of significant elements to the project. Station building, it's grade 2 listed from 1904, although the train shed section was life expired and beyond repair. And within the station's property footprint, and actually straddling platforms 3 to 6, is the Manchester Arena, which is one of the busiest event arenas in Europe, and it regularly discharges up to 10,000 people at night onto the station concourse. Also, Transport for Greater Manchester, TfGM, have a Metrolink tram network, which has a stop within Victoria Station. And as part of their own expansion plans to build a second city crossing, they required demolition of their entire infrastructure and then provision of additional platforms and complex track work. Our challenge, therefore, was to demolish the train shed and replace it with a large, lightweight structure, which also covered the expanded tram stop, whilst maintaining normal tram operations during the day, keeping the trains running for Network Rail as normal, and of course without any restriction whatsoever to the operation of the arena, which often means discharging up to, as I've said before, 8,000 event goers at night, and in fact their licence required was to provide capacity for discharging in an emergency up to 21,000 people onto the concourse. Oh, and as part of the agreement with English Heritage to remove the train shed, the station ground floor was to be restored to the 1904 splendour, including a stained glass cupola in the buffet, which again had to remain at least partially open for business. So, Network Rail procured the contract by normal competitive process with an extended preferred contractor stage, during which we at Morgan Sindall assisted Network Rail prepare and submit the formal planning application to Manchester City Council, a period of roughly 12 months. As part of this, Morgan Sindall engaged with our principal supply partners, namely Hyder Consulting as the lead multidiscipline designer, Severfield Watson for the main steelwork fabrication and installation, and BDP for architectural aspects. At the same time, and in parallel to the progress of this contract, Morgan Sindall, we had been for some time evaluating the advantages of linking 3D design modelling with scheduling, which is 4D, and cost 5D. And that's really for our delivery process. And we've been working with Rapid 5D to assess the VICO collaboration model. In the early discussions with Network Rail, we both agreed that Victoria would be an ideal project to conduct a live assessment. And by running the assessment alongside the conventional process, we would both have the opportunity to evaluate without risk or detriment to what would be a very high profile and challenging process. And what we certainly didn't want to do was distract the project team from their day job. In addition, Network Rail were extremely keen to assess how their asset management and maintenance strategy could be enhanced, particularly on major station complexes. So, in essence, by utilising Rapid 5D as our model builder, we created the 5D model, including the scheduling and costing, taking all the information from a live operation, allowing us to assess, learn and tweak. And again, as I say, without risk to the actual project itself. I've previously mentioned our principal supply partners, and each, of course, were selected as they are highly competent, working in their own complex structural environments. Hyder Consulting, for example, had already prepared their AIP designs for us in the Revit 3D modeling. Likewise, Severfield Watsons had prepared their steel designs and steel connections in Tekla, and BDP their architectural finishes in MicroStation. So, following the planning application, these designs were really quite mature, and we had no intention of changing those or diverting those teams from their own assurance processes. So, with Rapid 5D, what we did, we sat down with our partners, and as Russ will explain, we reached agreements that enabled us to take these individual models, federate them, and then we could run the model alongside the processes, and we could assess advantages, disadvantages, and we could see then how, excuse me, we could see then how we were going to deliver and future projects. Hyder, as lead design, remained in full control of their model and coordinated the associated design packages, and Severfield Watson likewise carried on with their connections and produced and went into fabrication. So I've explained what the work is and why we've built the model. Now I'll go over to Russ to explain how we did it.
Thanks, John. So just before we carry on, there are actually, we've got some incredible attendance today. There's over 420 people with us today. So hopefully we're getting some good questions coming in. Please keep asking them. One of the things we did initially was to map out the BIM process with the Morgan Sindall team and their supply chain. BIM is obviously not about software, it is about that process. So one of the things we did collaboratively with those who were going to be involved was establish a set of BIM protocols within the design team We helped them develop models, and when we started to look for things like quantity takeoff, we had to ensure that the models they were producing were not just fit for drawing production, but they also met the requirements to produce quantities later on in the process. So we did a bit of QA, and we worked collaboratively to solve those problems. We did some early stage clash detection, fed those back to the design team to ensure what we were producing was constructible on site first time. And we also migrated the traditional cost data from the traditional process across into Vico Office from Trimble. The main reason was we needed a baseline to compare our BIM data against and see what was happening. We added the work packages to that as well, so we could track those in comparison to the traditional process. And with that baseline of data imported, we could actually save a quantity and cost version of all the numbers from the traditional process, which we'd imported. And what we then did was, as the models were delivered by the design team, we began to replace those baseline quantities with the model-based quantities. What we then did was we were able to save another version of the cost and quantity that was now driven by the model, and we compared that against the baseline. That then enabled us to identify where there were changes from the initial estimate, be it quantity or cost, and we were able to use those to identify benefits and also where we were going to have to maybe move budgets around. We then mapped the same quantities and cost items to a schedule, a program of work that was provided to us by Morgan Sindall. The difference of using Vico Office is that we use the location-based planning methodology as opposed to critical path methods. So we actually had to cut the locations to reflect how the project was being constructed in terms of sequence. We then had to mirror the logic of the program we were given. And what we were able to do is analyze that program using the BIM model and the 4D simulation and start to advise on possible optimizations using a different methodology. And we actually took things one step further than we'd even planned at the very outset, which is as the project sort of developed over time, we were able to look at setting out and surveying and doing comparisons of as-built data to the model directly from the field. So what was the purpose of this process? We were looking to enhance capabilities using this process and compare it to what we do traditionally. We were hoping to get better and more effective collaboration. We needed to check interoperability. As John's mentioned, we were already using several different softwares from several different developers. We needed to check we could get the data together, and the data became key. We also need to look at the infrastructure specialities of Manchester Victoria Station. There are some building elements to the work. There's also some civil engineering aspects to the work, but we have one consistent set of data for the entire project. So we needed to be able to bring everything together. We also needed to do it transparently. Network Rail were very interested in what we were doing. We needed to be able to show where particular numbers had come from and track it back to the original source with confidence. And that also led to a communication potential improvement in how we transfer data, how we communicate with different people in the supply chain and our clients. And as I said, we also wanted to look at maybe getting BIM out of the office, out of the site office even, and actually out onto the field. So in terms of collaboration, we were talking about aspects of design, time aspects, cost aspects, taking things out to the field. We were involving a lot of different parties here, and their information was coming from a lot of different sources. One of the key factors we found was that if all the stakeholders could bring all their data together into one central pot, it reduced double working, it reduced the amount of times we were having to move data between solutions as well, and there was no need to reconcile varying data at different stage gates or between different disciplines. So it actually starts to become more than the sum of its parts when you put the jigsaw together. BIM itself, we started to find, didn't represent a new discipline. Instead, we found actually by carrying out training, upskilling the existing project team from top to bottom, it actually let them leverage new techniques and gain that benefit for themselves. And they actually then carry that knowledge forward as part of what they do in their day job to the next project. So Using Trimble's Vico Office, we were able to start to actually manage this collaboration where we have a 3D model, a 4D simulation, the project quantities and costs, and also the project schedule and program all in the same place. So we start to carry one version of the truth. One of the reasons we did this was that it's a very complex project. One of the only ways we could start to really coordinate things and compare it to the 2D process was to bring a 3D model together, especially with the torus roof. And if you look at things like the structural steelwork, it's probably the most complicated shape you could ever have, a section of a torus. To calculate the quantities from that traditionally was very time consuming. One of the comparisons we found was by using model-based quantities, we were able to generate those quantities in significantly less time and then link those to the cost and schedule. And we knew those figures were also more accurate. And that enabled us to start to interrogate that information and have informed decisions later on in the process. In terms of interoperability, we have several different solutions that were in use on the project for the designers and the steel fabricator. One thing we didn't want to do was specify which solution they used. So the reason for that, it was we don't want to tie one hand behind their back. They pick their solutions for a particular reason, and that's because it's best for what they need to do and their design work. One of the reasons Morgan Sindall came to Rapid 5D and we advised to use Vico Office was that it was capable of reading several different formats, and in the case of this project, we used Bentley MicroStation, Revit, and Tekla Structures as well. But by bringing them into this neutral environment, it meant everybody could access them. We could see all those different solutions working together at the same time without any of the interoperability issues. The way Vico Office communicated using specialist publishers also meant that we could ensure that the data that came across maintained its integrity and we didn't lose any information in the process. So here we can actually see the model as we started to federate it together. We're looking here at some of the structural work, the large culvert. So one of the things John didn't mention is that there's actually a river running underneath the station that they had to coordinate themselves around as well. So even though it's a piece of existing works, we actually put it into the model to ensure that piles and things weren't impacting on that. And as you can see from the left-hand side, we have several different modeling solutions in here. The Revit is the little purple R, Tekla is the little blue symbols, and then the little red symbols. Actually, we took initially on this project the Bentley information into a DWG format and then imported that into Vico Office. As we moved through this project, working with Trimble, we were able to produce a Bentley publisher, which is now standard, which meant we could get even better data directly out of Bentley into the project. Some of the data that exists on construction projects isn't currently in the realm of 3D. There's not a problem with that. We need drawings that show specific details, things like geotextile grid, drainage details, things like this. It would be very time consuming to model these. Would we get enough bang for our buck if we did? Probably not. But without reviewing that additional information, we can't arrive at accurate prices, accurate durations, and we don't have all the information for the project. So it became necessary to integrate both the 2D and 3D data together and also tie it together with alphanumeric data, things like the specification, the estimate, the schedule, which don't exist in the model world until you actually link them to the model. So to give this complete picture, we started to actually place 2D documentation into the 3D model, and this also enabled us to check that the model was matching the contracted drawings. Since this model was being done as a collaborative exercise, it didn't form part of the contract, so we needed to gain some confidence in it. This also enabled us to start to build data together in one place, which can start to lead to data handover for Network Rail, either attached to the model or potentially one of the future steps we might be looking at is a basic COBie output for them to meet the requirements. But unless we put all the data together, we aren't able to do that. So the interoperability for the data became very, very important as well. I've mentioned infrastructure specialities. There are very different techniques that are both being used in the same place on the same project at Manchester Victoria. The items that are for the tram network for Transport for Greater Manchester are very linear, very traditional civil engineering techniques. They use things like time change programs. Everything is broken down by location. But when we begin to look at the structure of the roof and the more building type element, especially the mezzanine underneath the roof, which is going to contain the shops and an access way to the MEN arena, that's not dealt with in the same way. It's dealt with very much in a traditional method of constructing different parts of the project. We needed a way to normalize this data and deal with it in the same way. So how this was tackled was using the location tool in DecoOffice to apply that to the cost and schedule, which meant we could actually deal with the building elements in the similar way that we dealt with the time changing schedules, but still satisfy the building requirements and the project team for what they needed to get out of it. So by using a model, we were able to visualize those building locations by zone, by floor. And again, this has an output moving towards handover in where assets actually belong. By having both quantity and cost by location, it's possible to see where the value is spread throughout the project. This can also be coupled with an asset-based bill of quantities, so we can actually start to use data for cost benchmarking as well. And that asset-based structure also means we can start to hand over information from the project delivery team to Network Rail in a systematic and logical way. It's also improved the traceability and how we can track information throughout the project. And one of the big changes we made for transparency in comparison to the traditional process was we moved to an asset-based bill of quantities. So now we have an object that has to be constructed, we have the methods of its construction identified against it, and then the resources that feed those methods of construction. So underneath each asset, I can see how it's been built and what's been used to build it. So we can actually start to use that information in the future. This also gave ease of use. If I'm looking for the information about the model-based object, I can select it and I can actually see what it's associated with. And that also meant that it gave suitability for the project delivery team. They could start to get to grips with this fairly easily with a small amount of training. So with that transparency, we've picked on a nice simple example here. We've selected the primary steelwork, which are the ribs for the roof. On the left-hand side in our cost data structure, which is asset-based, I'm looking at steelwork and I'm looking at those primary ribs in that structure. On the right-hand side, you can see them highlighted in yellow on the model. And then on the bottom right, what you can see is that object identified and then the quantities that have been derived for that object to feed the cost plan and the bill of quantities. So very transparent, very easy to see. No need for a lot of spreadsheets or things like that or codes to track all this stuff. So this enabled the team to see where stuff was coming from. Another thing we started to improve as well was communication. Data based around a 3D visual representation is extremely powerful. A picture says 1,000 words. It gives us real-world understanding of things, and it actually enables non-technical engagement. A good example of this is the reinforcement. So the buttress walls that support the roof are extremely large concrete structures, but they take a very high load as well. So the roof doesn't actually load the grade 2 structure of the station itself. The rebar inside these is extremely complex to take those loads, and it also has to interface with some excessively large holding down bolts for the steelwork. One of the key things was to make sure these items were coordinated and perform clash detection on this. So we actually modeled up the reinforcement using Tekla structures, and were able to check that the holding down bolts weren't going to clash with any of the reinforcement. So when the guys were putting the reinforcement in place on site, we could also check things were going in the right place. But visually, what you see on the screen there, in each case for each buttress, is represented between 19 and 24 different drawings for each buttress. To be able to see all that information in a 3D visualization is quite different to trying to look at 22-dimensional drawings. We also took BIM out of the office, out into the field using some Trimble hardware, turtle stations and a connected rugged PC tablet. This integrated instrumentation enables us to take the whole model out to site, so the whole model is actually held on the tablet, and that enables us to track changes and deviations people are able to select setting out coordinates on the model and then actually directly set them out in the field without having to go back and carry out any calculation. It also enables us to identify and address issues early. We can survey points, compare them against the model, and decide whether they're in tolerance or not. This is all done in an automated fashion without having to get a calculator or a count pad out and do it by hand. That actually enables us to minimize calculation errors and actually get through things a bit quicker. One of the nice statistics we have is that the engineer who worked with this piece of equipment managed to survey 360 points in 6 hours, which is pretty impressive by any standard. The BIM to field and back also started to come to fruition. You can see the model from the 4D simulation on the left-hand side, and you can see the same stage gate on the right-hand side with a picture taken from site. Now, one of the things we found was it gave both Network Rail and the project team more confidence in the model as time progressed, because obviously we were running in parallel with the traditional process, and there was a bit of an experimental sort of air to things initially. As they started to see project delivery match what the model was saying, the team started to actually gain some confidence in that. I'm going to hand you guys back to John now, who's going to talk you over a little video we've got showing some of the actual works. So I'll just pass you back to John.
Right. We are now showing a time-lapse video of the RIB 9 installation. Now, RIB 9 was the largest of the RIBs. As Russ has explained, the Taurus RIB is situated on the main concrete buttress, lands on a column and the station concourse, and then cantilevers over the roof of the Victoria building. So at no point does it actually touch the Victoria building, which would, from 1904, would just not have taken that structure. So what you're seeing is a lift that was taken typically about a 6-hour lift. Unfortunately for us, the only possession over the tramworks was at night, and it was a 3-hour slot. So in actual fact, the first 3 hours of the lift were prior to the tram possession, where the crane took the weight, allowed the camber to take effect, and then as soon as we were granted the isolation and possession, the crane was allowed to turn, and we had 3 hours to place and locate and secure that rib. And there's the light, as it was an early summer job. So it wasn't quite as easy as the video shows, but nonetheless, it was really quite an effective and efficient method of installation. And I think what we would really like to emphasize is that with the model and using the model, we satisfied ourselves prior to the erection of any of the steel that all the various individual models, whether they be the Revit model from Hyder or the detailed connection one from Featherfield Watson, they were all federated and landed in the right place. So the first time a piece of steel landed, it was accurate. There was no sledgehammer required. There was no classic hot axe required, and everything slipped into place, and there were no possession overruns or difficulties for Network Rail or for the tramworks. The final picture is courtesy of Manchester Police helicopter, who came over one night as we were placing the beams. And what it does illustrate is the very tight city centre environment that we were working in. And it also illustrates the length of those beams. Each beam was actually 1,200 deep, 500 wide, and the longest beam was some 90 to 100 metres long. In fact, the helicopter is quite close to the top of the jib of the crane at this point. But nonetheless, it does illustrate the tightness of the site.
So thank you for that, John. That's been great. Just so people are aware, if people would like to talk about some of the things we've talked about today in maybe a bit more detail, we've got some recent event or some forthcoming events that you can see there, and IT have been kind enough to involve us in another webinar on the 18th of March, which we'll be doing with them, where we're going to talk about the truth about the common data environment as per the PAS 1192 standards. So what we'll do now is move on to the questions and discussion session. We've already had quite a few questions come in. What we'll try and do is work through all of them. If we don't manage to answer your question, what we will do is probably contact you guys with an answer via email after the webinar. So one of the questions we've been asked is, how is it ensured that all parties were working to the same grid and datum from the start? Probably one I can answer there. Initially, Hyders had produced the first model in Autodesk Revit, so we took that as a basis. We then received the model from BDP and MicroStation, and also then from Severfield, Watson and Tekla. When we set the BIM protocols, we actually established a project grid, which was actually established by BDP. They managed to produce a wireframe as a DWG file, which enabled them to coordinate with Hyders using Revit and Bentley for BDP. What we then did was we actually spoke collaboratively with Severfield Watson, and they were able to move their own model in Tekla to suit that. So there was a bit of coordination maybe after the fact to make sure everything was coordinated, but we used a DWG file of a net grid that was able to go into every solution. And actually, as we moved through the process, they found it was better to use an IFC for that than a DWG. So another one we've got here is a question probably for John more than me, which is, was an as-built model produced and at what stage of the process did it become superfluous?
Yeah, I think what I'd like to emphasise is that at all parts of this particular contract, this model and the VICO model have been run in parallel to the normal construction and delivery process. So in fact, we have been carrying out and producing as-built drawings in the normal conventional sense. So the as-built model, as it is being constructed at the moment, contractually is superfluous, but from a practical point of view, we are using it to feed back to both our design teams and our delivery teams on the performance, and in fact it is going into our future projects that are starting off now. So at all times it's been run in parallel. Russ?
So the next question we've been asked is, did you find any difference between the performance of the models held in DWG and DGN files? We did find some difference in performance using the DWGs, especially when we exported them out of MicroStation. It was one of the reasons we actually then started to talk to Trimble, and they were already developing a plugin for a direct publisher from Bentley to VICO Office. So once that became available, we actually started to use that, and the quality of the data we managed to transfer then increased dramatically, which gave us much better performance and much more accurate data. So one for John, I think, was all the information added directly by the stakeholders, or did Morgan Sindall control the data before it was submitted to use?
Right. I think the answer is a bit of both, really. All the information was submitted directly into the normal design assurance process by our suppliers, whether they be Hyders, Severfield or BDP. All the information then that went into the VICO was controlled by ourselves and VICO. And in fact, in the review and the federating of that model, we decided whether, if we had an issue with any particular element of information, we decided whether we would revert to our designers or whether we would deal with the matter ourselves. And in fact, in the majority of the time, we decided to deal with the matter ourselves rather than distract the delivery team from their current work.
Okay. So I've just got another question coming in there. Just waiting for it to load on my screen. Just bear with me. Thanks. So we've got a two-part question here. That'll be why it's taking a second to just come through there. Did you integrate the models from different software packages using IFC files? We were integrating several different packages together, which we included Autodesk Revit, Template Structures, and MicroStation. When the designers were communicating amongst themselves, they were possibly using IFC or DWG formats to do that. Each of those solutions, by the time we sort of reached the midpoint of the project, had a direct publisher to EcoOffice, which enabled us to pull the data directly. So we didn't actually have a need to use IFC. What we did encourage everybody to do, though, was produce an IFC file at the same time, because we obviously need that to meet the requirements of level 2. So did we need it? No, not for our own purposes. Did we produce it? Yes, just to make sure in case anybody else did, it was available. And the second part of that question is, did you encounter any problems with these files, and would we suggest a standardized software package throughout the team on future projects? Because of the use of direct publishers, we didn't actually encounter any issues once we had them all. Would we recommend a standardized software? For federation, we probably would, and my suggestion would be make sure it's as neutral as possible so it can read as many file types as you need, and probably best to check that kind of thing on what people are using before the outset of the project. Like I said during the presentation, be very careful if you do try and standardize software that you don't tie someone's hand behind their back and reduce their efficiency and ability in the design or the model that they've been asked to produce. So another question coming through here. Were the project models able to be utilized for construction and logistics requirements relating to the wider site, utilities, interfacing projects, site traffic management?
Well, in short, no. Most of those items were being covered in the normal way and were well in advance of the model being completed. However, what we have learned and the lessons that we have learned, having had the model and being able to compare it, what we are doing now as Morgan Sindall is taking that forward onto the commencement of several other projects. And so we are embedding the lessons that we've learned now into the commencement of other projects, and those issues certainly are getting considered now.
So another question for us, have Network Rail taken control of the model and are they using it as a full lifecycle record for facilities using the elements of the structure?
Right. It's early days. The Network Rail and ourselves, we've jointly invested in the production of this model and the evaluation of it. And one of the, apart from the delivery of the project, Network Rail are extremely interested in the asset and the life cycle of the model. And so we are now currently looking what parameters are going to be suitable for Network Rail to take away from the model. And we do have to bear in mind that a lot of these station complexes are operated by train operating companies, for example, as well as Network Rail managed stations. And so we're currently giving consideration of how that can be best presented to the station operator to take that forward. But certainly it is the intention that the model and the data behind it and all the data tagging is made fully available for the facilities management and the asset life cycle.
Okay, another one probably for John here. How were the beams for the roof delivered to site? Were they delivered in pieces with their obviously quite extreme length.
Yes, right. Yes, as you noticed from the overhead photograph, the site was extremely congested, and some of the beams were 100 metres long. The beams, in actual fact, were fabricated at Severfield Watson's yard in Lostock, Bolton, maximum of 27 metres length. And they were brought to site and set up in jigs and welded into their full lengths. The complexity was that being welded into jigs like that once the beam had been picked up, it balanced into its pre-camber stage. So once the crane had picked the beams up from their jigs, they couldn't be put down. So it led on to extremely complex lifting operations and planning against wind effect, etc., to make sure that once we picked the beam up, we could do something with it.
Okay, we are getting a very large number of questions coming in, which is great. Like I say, we will get back to you guys, so we've probably only got enough time for a few more quick ones, really. How is the use of BIM limited by computer hardware? In the case of what was being done with Morgan Sindall, we used a hosted solution, so we're actually using the software on a server and people logging in for that. Probably the biggest limitation there was things like internet connections. We've done some pretty detailed work to enable that and make sure it's working well. So hardware in that case, because it's running on a server, actually became less of an issue. Another question here, what courses can a beginner take to enable enough competence to use Rapid 5D? Obviously, Rapid 5D are just a business, but if you're talking about using the solutions that have been deployed by Morgan Sindall on this particular job, if you drop onto our website, we actually run courses. Another one we know and I would recommend is the College of Estate Management actually have an introduction to BIM for construction, which is a distance learning course, so you can actually take it at your own pace. What is the key lesson learned from this project, which will become core for future BIM for infrastructure projects for Morgan Sindall, John?
Right. BIM is a philosophy, and at Morgan Sindall, what we've done, we conducted a lessons learned 6 months ago for the Victoria project. We've taken those lessons learned back into the office, and we've realised that to get the best out of everything that we've described today, particularly the costing and the scheduling and getting it in line, we've got to commit ourselves at tender stage. And we've now launched approximately, Russ, I think it's about 7 projects we've launched using the VICO. We've selected the projects for their complexity and suitability. And those projects now have gone through tender, and there's a number of them in contract, early contract and delivery stage, and they've got the costings, they've got the schedule, and they've got the models all lined up, federated, and on the elemental basis that VICO had just described.
Just 2 seconds. So next question we've got here is, how did you deal with clash detection from the various models, i.e. Revit, Tekla, Bentley MicroStation? We actually did the clash detection process inside VICO Office, so it meant we could actually do it on the federated model, irrelevant of which solution it had actually come from, and actually run the clash detection and reports in there. That enabled us to then feed those reports back to the design team, and they were able to amend their models based upon that information.
Yeah, I think I'd like to add at this point to just keep re-emphasising that this model was run in parallel to the normal IDC and design assurance process with clash detection, and Hyder Consulting had in their normal process of lead designer, they had carried out the normal clash detection process and were coordinating all the design on site. With the VICO model as that came on board, we were assessing the extra clashes to decide whether they were actually viable or simply for information. So it was a mix of the normal process, which was carried out very competently, and our additional information that we were able to make sure that it was a fully federated model. And that was a great advantage of working in parallel without importing risk.
Okay, probably a combined question for me and John now. Establishing employer information requirements, or EIRs, is the first step in the BIM process. Did Network Rail set out any such requirements?
For this contract, no. But it is obviously in their strategy. They publicly and very proactively worked with Morgan Sindall and ourselves that once the contract was in place to embed and construct this VICO model. So I would expect to see it in the future. Obviously, I can't speak for them direct, but they're extremely proactive.
And in speaking from Rapid 5D's perspective, we've worked on other Network Rail contracts since this one commenced, and we are starting to see them produce some very good employees information requirements. Another question around this thing as well is, in general, are clients equipped to define employees information requirements? I think there is some variation in that. Some clients are very proactive and very, very good at that. I think they generally get better results from BIM because they specify what they want. Are other clients as capable? Perhaps not, but this is a journey. It is a philosophy, like John says, and people are still learning. So if you aren't getting an employer's information requirements and perhaps you think you need one, it would be prudent to be collaborative and go and have that discussion with your client rather than try and carry on and hope you can provide what you think they need. So probably our last question today, I think. Did you find that suppliers were forthcoming with their models and the object within them, or did they try and hold on to them?
No, absolutely no problem. Everybody was very proactive. We held a couple of early workshops as soon as we could get all ourselves together. There was no problem at all. Everybody very keen to work together, and I think that was one of the great benefits.
Brilliant, thank you, John. So just to sort of summate that and close things out today, please note, I know a huge number of people have asked if this presentation is going to be made available after we've finished. As an ICE member, you can view this. It'll be available probably early next week, along with all the other previously recorded lectures, just by visiting the recorded lectures section of the ICE website. For future and upcoming lectures and events, I'd encourage you to visit the website as well, which is www.ice.org.uk. And also the 2015 ICE BIM conference will be held on the 21st of October this year in London. So plenty of warning, please get that date in your diary. It'll be excellent. I know it's been one of the best conferences I've attended on BIM over the last couple of years. And on behalf of the Institution of Civil Engineers and everyone listening today, I'd like to thank our speaker, John, for his presentation, and we hope you enjoyed today's webinar. Thank you very much.